What is it that is not correct about the current operating state of this hydraulic system? Take a moment to analyze it. Perhaps you recognize this variable displacement pressure compensated piston pump. For more information on this type of pump, see our video, Pressure Compensated Pump Adjustments, Part 1. If you are already trained on this type of pump, then you know that this spool, this spring, and adjustment are there to detect the maximum safe system pressure. Should that pressure occur, the pressure compensator will extend the control piston inside the pump, moving the swash plate to a near zero angle. When this occurs, the pump will be set in a near zero displacement mode. The pump, together with its pressure compensator, will be able to hold the maximum safe system pressure while producing very little flow. And in so doing, it will save lots of input energy at the prime mover and will help avoid the buildup of excessive fluid heat. The only purpose for a relief valve in this type of system is to respond to very sudden and short duration pressure spikes. The primary point of control for maximum system pressure in this type of system is the pump's pressure compensator. But at this moment, we can see that the pump swash plate angle has remained at the maximum angle, that our pump is in maximum displacement mode, and that all of our pump's flow is passing through the relief valve. Without the help of a cutaway and flow arrows on a normal hydraulic system, we might detect this condition by the sound that the relief valve makes. We would probably also notice, if we measure temperatures, that the hydraulic relief valve will be the hottest component in the system. If I tell you that the machine manual says that our hydraulic system pressure should be set no higher than 1100 psi, then that is another way for us to know that the system is currently maladjusted. If we put a wrench on the pressure compensator and turn it counterclockwise just a little bit, and notice that the system pressure is not falling, this is yet another indication that the system pressure is currently being regulated by the relief valve. The relief valve is currently set lower than the pressure compensator on the pump, and this is backwards. It is not correct. If we keep turning down the pressure compensator, we might find that we are able to reset the pump to the 1100 psi required maximum system pressure, and we have restored the system to its normal state. It is fairly normal for the relief valve to be set at 300 psi higher than the pressure compensator on the pump. Some hydraulic systems set that relief valve only 150 psi higher than the pressure compensator. It is always best to check your machinery manual and find out what the manufacturer recommends for the settings on your hydraulic system. In the next part, we will look at what happens when the relief valve and the pressure compensator are set at nearly the exact same pressure.